to start looking at the graphs of quadratic functions and what they look like and use that to apply to certain applications. So I'm just going to go ahead and type in y equals x squared into Desmos, okay? And what you first see is that it's kind of like this U-shaped parabola is what it's called, okay? A linear equation, remember, is y equals something like x plus 3. That's going to just create a straight line, okay? But a quadratic, so anything that is raised to the second power, where the highest exponent is 2, is going to have some type of U-shaped. And I want you to think about why. If we look at the table, okay, so think about this. If we plug in -2 for x squared, -2 times -2 is positive 4. And that's the same thing when we plug in 2. So when we plug in 2, 2 squared is 4. So what we get is this very symmetric U-shaped balanced graph of a quadratic. So it's, you know, as x gets larger, it goes down, and then at some point it goes back up, okay? And I can manipulate this equation in all different ways. So if I have y equals x squared and I put, you know, plus 3, it's going to move the function up 3. Okay, and we're going to learn a little bit next chapter about how functions move and why and where. But for right now, just understand that, you know, I can put a 2 out front here, and it's still going to be the same type of shape. It's just going to get skinnier or fatter. I can even put minus 2x in here. I could put plus 10x in here, and I still have that U-shaped graph as long as the highest exponent is 2. Okay. The minute I change that to a linear, it becomes a line, okay? I can also be writing these in any fashion, so it doesn't have to always be in standard form. It could be something in this nature where it's in factored form, but we still, if you look here at the red one, we still have a U-shaped. For today, we are just going to be looking at ones that are U-shaped that are opening up, but in a few weeks or in a few days, we're going to start talking about what happens when we put a negative out here in front of that x squared. So if I put a negative in front of both of those, if you see, look what happened to my graphs. They are now opening downwards. Okay, so we're going to be looking at those type of parabolas. Quadratic equations only open up or down, never left or right. Those would not be functions. So if we go back to our notes here, okay, you know, just a picture of the quadratic. What we want to focus on here is we're going to solve these and kind of try and figure out the relationship between when we solve an equation and the graph of the equation. So I'm going to go ahead and just solve all 3 of these. And we solve these by setting them equal to 0. So if you read the directions, it says solve the equation for when y is 0. So what I'm going to do is I'm going to plug in 0 for y, and I'm going to solve this equation. Now remember, our goal is to set it equal to 0. That's done. And then the second thing to do is to factor. So I need to ask myself if there's a greatest common factor, and there's not. So I know that I'm going to have 2 binomials. This has to be x and x, and then I'm going to shoot for 7 and 3. This would give me 7x and 3x, which would be good if they were both negative, correct? And then -7 times -3 is positive 21. So I'm going to set x minus 7 equal to 0 and x minus 3 equal to 0. So I get 7 and 3 as my solutions for this one. If I set the second one equal to 0, my next step is to factor, and I don't have a GCF. 2 and 2 is never going to get me 5, so I'm going to try 4 and 1. Let's see, 4x, 1x, both positive. That works great. So I set x plus 4 equal to 0 and x plus 1 equal to 0. When I subtract the 4 over, I get x equals -4. When I subtract the 1 over, I get x equals -1. And this last one, when I set equal to 0, my next step would be to factor. I'm going to try x and x. I'm going to try 3 and 2. I have 3x and 2x in the middle. I want it to be negative, so it looks something like that. When I set x minus 3 equal to 0 and x plus 2 equal to 0, I get positive 3 and -2. So now I want you to look at the graphs of these okay, and see if there's any correlation. If you see or notice anything about these x values and your x values there. So if we said x is equal to 7 and we go on our x-axis to 7, okay. And this one we're saying x is equal to 3, and if I go on my x-axis there is a point at 3. Okay, and this similar situation happens here. I get -4, and there's my graph. I also get -1, and that matches there. Same thing for this one. X equals 3, positive 3 is right there, and x equals -2 is right there. So what we notice is that our solutions are where the graph crosses that x-axis. And wouldn't that make sense? Because from the original equation, we set y equal to 0, and we said 7 is x. Well, if y is 0 and 7x, then we technically have that point 7, 0. That's one of my x-intercepts. And another x-intercept is 3, 0. Because when y was 0, x was 3. Remember, our ordered pairs are x, y. So that's why we can call these our zeros, our solutions, our roots, or our x-intercepts. But what's important to note is that we have where those solutions are is where the graph crosses the x-axis.